The topic today is density. Let's take a look at a few problems here. First item is to solve a few basic density problems. All right, so quick density. So the formula for density is the mass divided by the volume. So it's a way of expressing how compact a substance is, how much mass there is in a given amount of space. And you could kind of illustrate it like this. Some substances are less compact, and other substances are very compact. So the matter is very close together. The atoms or molecules are very close together. So this is a way of measuring that. And so let's do our first problem. High density lipoprotein, HDL, contains large amounts of proteins and small of cholesterol. 0.258 gram sample of HDL has a volume of 215 centimeters. What is the density of the HDL sample? Okay, so we have lots of words here, and the problem though is not really that complex. Basically, we just need to plug this into the formula, mass divided by volume. So we have our given values. We have a mass, which is 0.25 grams, and we have a volume. Volume is 0.215 centimeters cubed. And a centimeter cubed, by the way, is the same thing as a milliliter. Right? One centimeter cubed is 1 milliliter. So we could also express this as 0.215 milliliters. And so we're just going to be plugging this into our formula. Density is the mass by the volume. And so we just take the mass and we plug 0.25 grams. The volume we substitute into that. I'll just use calculate 1.20 grams per milliliter. Remains there, grams per milliliter. That's why we have our unit, gram liter. Write it like this: 1.20 per every 1 milliliter. 1.20 grams per milliliter. Those all mean the same thing. The slanted line, or written like this, or written like this, it all means the same thing. We can put our answer in a box as well. You know, I made a mistake. Switch D to M. These should all say D. So density. Okay, the second example says low density lipoprotein, LDL, small amounts of protein, amounts of cholesterol. 0.380 gram sample of LDL has a volume of 0.0 meters cubed. What is the density of the LDL? We have basic. I'm going to solve it, but it would be a good chance to your skills and try solving it first before. We have the same idea here. We need the mass. Mass is given to 380 grams. 0.380 grams. We have a volume, which is 0.362 centimeters cubed. And so centimeters cubed, or we could say milliliters, it's the same thing. So we just plug this into density. Density is mass over volume. We're going to plug numbers 0.380 grams, substitute the volume 0.362 milliliters, and just calculate. Comes out to 1.05 grams per milliliter. Okay, our next set of problems. Density by volume displacement. Okay, so basically here, often when we find density, we find the volume through using the method of volume displacement, where we place in water and measure how the change in volume, measure the change in volume of the water. So the problem, it says a lead weight used in the belt of a scuba diver has a mass of 226 grams. When the weight is carefully placed in a graduated cylinder containing 200 centimeters cubed of water, the level rises to 220 centimeters cubed. What is the density of the lead weight in grams per centimeter cubed? Okay, so again, we have the mass is 226 grams. Now in this case, we have an initial volume and a final volume. So the volume is going to be the final volume, V sub F for final volume, minus the initial volume, V sub I for the initial volume. So V sub F then is 220.0 centimeters cubed, and V sub I, the initial volume, is 200.0 centimeters cubed. So we can see then that the volume, or the difference, the change in volume, is 20.0 centimeters cubed. Okay, so now that we have the mass and the volume, we just go through the same process. Density is the mass divided by the volume. So we have 226 grams divided by 20.0 centimeters cubed, and so we just calculate to 11.3 grams per centimeter cubed. Okay, so second example, 0.8. It says a total of 0.5 pounds of glass marbles is added to 425 milliliters of water. Water level rises to a volume of 528 milliliters. What is the density in grams in grams per centimeter cubed of the glass marbles? Okay, so we have pounds here of glass marbles added to a certain amount of water. The water changes to this volume, and we want to know the density in grams per centimeters cubed. So first of all, we have this value in pounds. If we're going to have grams per centimeters cubed, we're going to change that. So let's write the mass in pounds, 0.50 pounds. We're going to need to change this to grams. So in order to change that to grams, we'll need to look up a conversion factor or equality between grams and pounds. So we'll be using our table from the textbook, chapter 2. Find that table here. All right, here's that table. And so we need a link between pounds and grams. So we have pounds right over here. From pounds to ounces, and let's see. Okay, we have this one here. That would be more direct, a link straight from pounds to grams. All right, so we can do our conversion using this equality. 453.6 grams per every 1 pound. So let's go ahead and do that conversion. So we have 0.50 pounds for every 1 pound. We have 453.6 grams. Pounds cross out. Do the math. And so that gives us 226.8 grams. And to 2 sig, that's going to be 230 grams. Okay, so now that we've converted to grams, we need to find the volume. Again, we have an initial volume and a final volume. So our initial volume is 425 milliliters, and our final volume is 528 milliliters. So V sub F minus V sub I with volume. V sub F is 528 ml minus 425 ml. So our volume then is going to be 103 milliliters. Okay, so now it's just a matter of doing the formula for density mass over volume, and we can substitute into that the mass 230 grams and the volume 103 ml, and just calculate that. And so that comes out to 2.23 grams per milliliter, which is the same thing as grams per centimeter cubed. Okay, there's our final answer. Okay, let's look at just one more type of problem. Using density as a conversion factor. Using density as a conversion factor. So let's take a look at a few examples here. If the density of a sample of skim milk is 104 grams per milliliter, how many grams are in 0.50 quarts of skim milk? So we are given the density this time. It's 1.04 grams per milliliter. And we want to know the number of grams, so the mass is the unknown, and we want grams in a certain volume. So our volume then is 0.50 quarts. There are a couple of ways to do this. Way would be to plug this into the formula. Algebraically, we could sort of substitute the density into the formula, the volume right there, and just solve algebraically for the mass. But in chemistry, we love conversion factors, and since we're going to have to convert from to a metric unit, milliliters, it would probably be easier just to set up a bunch of conversion factors. So let's go ahead and let's show how we'll do it in that case. Ratios of units can be used as conversion factors. A density value is a ratio 1.04 grams per milliliter, or vice versa. For every 1 milliliter, there's 1.04 grams. So we have an equality as well, 1.04 grams in 1 milliliter. And so we can use that as a conversion. We're going to need we need to go from quarts to milliliters. So let's go back to our table. We have quarts and we have milliliters, right, as equality. So let's write that down as well. So for every 46 milliliters, there's 1 quart. All right, so we can go ahead and set up our problem. We're going to be starting with the given value as we always do. Actually, density is going to be used as a ratio that will be used as a conversion factor. So it's easier to start with the thing that it's not a ratio. So we're going to start with this as our given value. So we have 0.50 quarts, place that over 1, and we're going to go step by step. So we have quarts to milliliters. So there's 1 quart per every 946.3 milliliters. And for a milliliter, there's 1.04 grams. And so that's going to give us grams, which is what we want. We're trying to find the grams. And so we're ready to just calculate. We just multiply those numbers. 0.5 times 9.46.3 times 1.04 comes out to 492 grams. All right, we have one more example. And it says how many milliliters of mercury are in a thermometer that contains 20.4 grams of mercury. Okay, so we're going to need to look up the density of mercury in this case. And so the density of mercury is 13.6 gram milliliter. And so I'm looking at the table from the textbook. It's right there. Density of mercury. It's on page 45. Okay, so we are given the mass. This would be our starting value, the 20.4 grams. 20.4 grams. And we want to know the volume in milliliters. So volume is unknown in milliliters. So we're going to take a similar approach here. Use our density as a conversion factor or equality. 13.6 grams are present in 1 milliliter. And so we have our equality here. We're going to start with our given value. That would be this one here. The one that's not a ratio is easier to start with. And so we have 20.4 grams. Place that over 1. Use our ratio for every 13.6 grams. There's 1 milliliter. And so we're ready to cross out units and calculate. Just 20.4 divided by 13.6. And so that gives us 1.5, 3 sig figs, add a 0, 1.50 milliliters.